Here's another problem. What three-digit palindromic numbers have sum of digits equal to the sum of the digits of the largest two-digit palindromic number? Well, do you know what a palindromic number is? If you've read the section, you do. If you haven't, if this is how you choose to start looking at this chapter, you might not. Okay, a palindrome is simply a number that's the same backwards as it is forwards. For example, 1, 3, 7, 3, 1. Now there's 13,731. The order of the digits, if you go through the number forward, is the same as the order if you go backward. So another example, 144. Let's go 7447. Okay. Now, those are palindromic numbers. Now again, what three-digit palindromic numbers have a sum of digits equal to the sum of the digits of the largest two-digit palindromic number? Pause and think about that a minute. Can you understand that question? Well, to understand the question, let's just take a phrase at a time. Like, how about the largest two-digit palindromic number? What's the largest two-digit palindromic number? Can you think of a two-digit palindromic number? Well, two-digit palindromic numbers would include 1, 1, 2, 2, 3, 3, numbers like that. 4, 4, and so on, and down to 9, 9. Okay? So those would be two-digit palindromic numbers. Now, what's the largest two-digit palindromic number? Well, if we look at these, it's 99. Now, what are we talking about here? We're talking about the sum of the digits of the largest two-digit palindromic number. What's the sum of those digits? Well, the sum of the digits of the largest palindromic number is 9 plus 9, or 18. Now, we're getting somewhere. We're interpreting all this. Now, if we go to the first one, we're asking what three-digit palindromic numbers have sum of digits equal to the sum of digits, etc. That means equal to 18. Three-digit palindromic number, sum of digits equal to 18. Now, we didn't really stop and make a plan here. We just kind of dived in. But really, the plan is implicit. The plan is to interpret this thing from the end back to the beginning. We start with something we can understand, two-digit palindromic numbers. Then we look at the largest two-digit. We're analyzing this statement one phrase at a time and seeing what we can come up with. Okay, now, what three-digit palindromic number has sum of digits 18? Well, let's look at some three-digit palindromic numbers and whether they have sum of digits equal to 18. Three-digit palindromic number, how about 1, 1, 1? That's palindromic. Or 1, 2, 1, 1, 3, 1. Okay, we can put any digit between two ones and we have a palindromic number. Or how about 2, 1, 2, or 2, 2, 2, or 2, 3, 2? Now there's a little sub-strategy in here. I'm listing these things in order of size. But we could go all the way up to 9, 1, 9, 9, 2, 9, and so on. Now, do any of these numbers have sum of digits equal to 18? Well, let's see. 1 and 1 and 1 is 3. That's too small. 1, 2, 1, 1, 3, 1. Let's see. Is there anything we can do starting and ending with 1 that'll give us a sum of 18? Well, 1 and 9 and 1 is only 11. So 1 is too small. It doesn't give us a palindromic number whose digits equal 18. And similarly, 2 is too small. 292 is the largest number we can get with a 2 in front of it. So that only gives us a sum of 13. 392 isn't a palindrome. 393, that sum is 15. 494, the sum would be 17. It looks like we're going to at least have to have 5 to make a sum equal to 18. So five something 5. What are we going to put in between the two 5s to make a palindromic number with a sum of digits equal to 18? Well, it'll be 585. Is there something we can put in between two sixes to make a palindromic number? Yeah, we can put a 6 here. Between two sevens, yeah, we can put a 4. In each case here, the sum of the digits is 18. What about between two 8s? Well, we can put a 2. What about between two 9s? Well, 9 and 9 itself is 18. Of course, I guess I haven't really listed all of them, have I? Did I leave something out? Is there something we could put between two 9s to give us a sum of digits equal to 18? Sure there is. You put a 0 in there. So I maybe could have listed 101, 201. Now you see, if we had stopped here and said that's it, 919 is too big, and gone with this listing, then the next step could have been very important. After we carry out our plan, which is to list these things in some kind of order, we can go back and look and check. And we can see, whoa, wait a minute. We left out 909 here. Okay? By doing this scheme and by being a little bit careless here, we might have missed something. Okay, in any case, right here are what I believe are the 5 palindromic numbers, 3-digit palindromic numbers, whose sum of digits is 18.